We are at the beginning of our discussion of many important statistical tools. Before we begin our discussion on confidence intervals, I would like to review some important statistical concepts. Statistics is a powerful set of scientific tools used to extract meaningful information from numbers. In many top-performing companies, professionals use statistics to make database decisions. These are decisions that have a 95% probability of being correct, which means there's a 1 in 20 chance of being wrong, and that's considered acceptable by most professionals. If you were to take those same odds to Las Vegas, you would walk away a very rich man in a short period of time. Many of the hypothesis testing methods we're going to discuss require that the data are normally distributed or approximately normally distributed. Let's take a look at some common approaches that statistical practitioners use to determine if the data are reasonably normal. One approach is to plot the data on a frequency plot, like a histogram, and see if the data have a bell-shaped curve. Again, that approach is a little subjective. Another approach is to perform distribution fitting tests, Shapiro-Wilk, the Anderson-Darling technique, or the goodness of fit tests are three commonly used tests to fit the data to a distribution, in this case, the normal distribution. Caveat, if the sample size is small, i.e. less than 30, these tests have low statistical power and may not detect a deviation from normality when one exists. When the sample size is small, one approach I like to use is the normal probability plot. And that's this plot here on the right. And I had 10 data points, and they fall close to this line going through the center of the data. As long as the data are within what we call the fat pencil test, where you take this plot and lay a theoretical fat pencil on this line through the data, and all of the data points are within the width of that fat pencil, here shown with these two red lines. So we would look at these 10 data points and presume the data comes from a normal distribution. These same 10 data points plotted in a histogram would look like this. When the sample size is small, less than 30, the histogram is a little hard to interpret. It's a little subjective as to whether or not the data fit a normal distribution. Let's do a little review on what a histogram is. It's a frequency plot, and it gives us the number of occurrences we got a particular measurement. For example, when we look at this histogram here, up the vertical axis is the frequency. We got a value that fell within this interval, say from 28.75 to 29.25. We got one value that fell into that region. And if we go over and look at the probability plot, we can see that that's this data point here. And from the interval from 29.25 to 29.75, we got two occurrences, two data points that fell into that region. And if you go over here again and look at the probability plot, we can see that it's these two data points here that fell into that region. And then we had two more data points that fell into this interval of 29.75 to 30.25. And we can see that again over here. It's these two data points that fell into that region. So again, the histogram is a frequency plot, the number of occurrences that we get data that fall into these different intervals, and that gives the data shape. And if the data are normally distributed, that shape will look or resemble a bell-shaped curve. Having looked at these two plots, I would conclude that both the histogram and the normal probability plot indicate that the data are reasonably normally distributed.